Okay, the electrolysis of acids. So it's something we should focus on now. There's a couple of special cases here, and this is a lovely piece of equipment that we use to electrolyze hydrochloric acid. Okay, you can see here we've got some bungs with cables going through leading to platinum electrodes. This is the anode, and you get chlorine gas formed at the anode. Cathode, hydrogen gas formed at the cathode. And this is open here so you can add more solution as the solution is used up. There's two taps here so you can take off the gases. You can tap off the gases as they're formed. Okay, it's called a Hoffman voltameter. Beautiful piece of kit. Right, now let's have a look at what's happening. So whenever you do an electrolysis, especially in solution, it's important to get clear which ions are present. Now the compounds that we've got are hydrochloric acid, solution, and we've got water. And these produce which ions? Well, both of them will give me some hydrogen ions. 99.99999% of those hydrogen ions will come from the acid. Very, very few water molecules break up, remember. And then the anions present, so this is my cation. I've only got one cation. The anions present are chloride ions from the acid and hydroxide ions from the water. So which of these go to the anode? Well, this obviously it's the negatively charged ions, and because we've said the chloride ions are highly concentrated here, it's concentrated hydrochloric acid, then it's the chloride ions that discharge. Okay, always the same equation. There's only one choice. It's Hobson's choice at the cathode, isn't it? The hydrogen ions go to the cathode, and again, same equation, hydrogen gas is produced. Now, it's quite a subtle point this, but it's worth noting. There are 2 electrons involved in this equation, and there are 2 electrons involved in this equation. Okay? So if we added these 2 equations together, then the electrons would cancel. So you get 1 mole of chlorine gas produced every time 2 electrons are lost, and you get 1 mole of hydrogen gas produced when 2 electrons are added to the hydrogen ions. So you get the same volume of these 2. So you get the same volume of gas. Okay? Let's try it for dilute sulfuric acid. Same process. Which ions are present? Well, you've got lots of hydrogen ions, and you've got a sulfate ion, and you've got a hydroxide ion, haven't you? At the anode, what's going to happen? Well, you've got these 2 ions, the anions going to the anode. Sulfate ions never discharge, so the hydroxide ions discharge. And this is an equation that you must learn. The magic number is 4. 4 hydroxide ions give 1 mole of oxygen, 2 moles of water, and 1 mole of electrons. 4 moles of electrons. 4 electrons. Right, at the cathode, well, there's only one choice. Hydrogen ions go to the cathode. They gain electrons to produce hydrogen gas. Now, there are 4 electrons here and 2 electrons here. So in order to make the electrons cancel, if I wanted to add these equations together, to make them cancel, I would have to multiply this second equation by 2. Okay? We have to have the same number of electrons because essentially the electrons that are being used up are the electrons that are being given. So they're going round the circuit. So we have to have the same number of electrons. So now the electrons balance, it's 4 and 4. But notice the volume of gas. 2 moles of hydrogen gas, 1 mole of oxygen gas. So when you look at the diagram, you can see there's twice as much hydrogen as there is oxygen. That's the explanation. It's to make the electrons equal, you have to multiply this by 2, so you get twice as much hydrogen. Okay, there are 2 specific examples. Now, something we need to be aware of is that hydroxide ions will discharge in these solutions. They will discharge when they're with nitrate or sulfate ions, because they won't discharge, or when they're mixed with a dilute solution of halide ions. So if we've got very, very dilute solutions of chlorides, bromides, or iodides, then the hydroxide ions will also discharge, or will discharge instead. Okay, so in a question, if they say very dilute sodium chloride, then the hydroxide ions will discharge. If they say concentrated sodium chloride solution, then the chloride ions will discharge. Right, have a look at the page indicated. Read pages 78 and 79, I imagine, and then try the questions.